Okay. Hey, everyone. Welcome to Verkle Implementers Call number 3. This is issue 829 in the PM repo, where you can find the agenda. We have a few things on the agenda today, starting with an update from Guillaume on the overlay transition, followed by a discussion on relaunching the Houston testnet. Then a few things on Verkle SnapSync, and lastly, state expiry as a potential alternative, actually, to the overlay transition. And then if time remains, we may try to touch on pre-image distribution as well. Okay, Guillaume, do you want to kick things off with the overlay update?
Yeah, sure. Well, it should be fairly short, actually. Let me just share my screen. Where is the too many tabs? It's always the same problem. No, it's not the one. Give me a moment. Sorry. Is that the one? Okay. Well, then, if I can't find I won't share my screen. But anyway, so we have been trying to optimize a bit more and make more performance measurements for the transition. So everything is shared in the document, like the document I'm going to copy paste right now. Geez, I can't find anything today. Oh, here it is. So the the results is well, for ARM basically. So we started running on an, let's say, average machine, an AMD Ryzen 7, and also on the ROG 5B, which is a Raspberry Pi on steroids. So currently, at least our test code doesn't have any of the ISM assembly, like any optimization for the crypto. So the performance for ROG 5B is pretty bad. So with basically, if we were to transfer 1,000 keys per block, the result would be roughly half a second on average, and in the worst case, one second extra compared, like, for a given block production. And as a reminder, if we only translate 1,000 blocks per, 1,000 leaves per block, the overlay transition would take 5 months, which is, still acceptable, but far from ideal. And if we decide to transfer 10,000 leaves per block, the transition would take 15 days. So yeah, I would say a month, 2 months might be acceptable for this overlay method. But by the look of it, and we still have some avenues to explore, but if they don't deliver any significant improvement, we have to choose between dropping the, like, lower power devices like the ROG 5B, and or the alternative being having a 6 months transition. So yeah, like, no definitive, no conclusive answer yet, because there's still some things to try. But by the look of it, I mean, my preference would be to give up on the ROG 5B, at least during the transition. Make sure it still is possible to run Verkle Tree on those machines, but we would tell those owners, those validators, to just wait like 1 month and sync again. Yeah, like I said, it's not great, but it's definitely acceptable. And yeah, I think that's pretty much it. Oh, some people raise their hands. Yeah, Josh.
Maybe a silly question, but just to clarify, when we say we would have to choose between dropping those lower powered devices, we just mean they would not be able to participate in the actual transition. Is that correct?
Yeah, I mean they would probably fail doing, like they would probably not be able to follow the chain, and or more exactly, they would not be able to produce blocks on time. And so they would have to, yeah, they would just fall off the edge, and they can probably join later, but during the transition it might be extremely hard for them to follow the chain fast enough to be able to produce blocks. Gabriel?
Yeah, so one question. You mentioned that, if we process 1,000 leaves per block, then we end up with a 5-month transition period, whereas if we do 10K per block, we get 15 days, which is preferable. Could you elaborate a bit on why a longer transition period is problematic? So my understanding is that syncing, if you try to sync up a new node when the transition period is being done, then that tends to be problematic. But are there other like downsides, or is that an actual downside?
I mean, there's several downsides. They all come up with, for example, the sync. If the question is, do you want to create a specific method, a specific sync method? And there's another item on the agenda about the sync, so I guess we can plug back, like we can connect to this when we get to that point. But the problem would be if your transition is only 15 days, I would say, do you really want to care about designing a syncing method for just those 15 days when you could just snap sync to just before the transition and then full sync for 15 days? It's, once again, it's not great, but you don't need to create a syncing technique specifically for this transition. So yeah, if it's a lot of things like this. Like there's a lot of problems. You could say, well, we have a good enough method that we can deal with for a period of 15 days, maybe a month. But if it's 6 months, you definitely need to be able, like, you can't tell people, okay, next time, your next window, your next opportunity to sync is in 6 months. That's not realistic. And there's another reason that I was thinking of, but just I can't remember now. Yeah, sorry, it will get back to me.
Yeah, cool. Thanks. So it's mostly about the inability to sync during that transition period for new nodes. But
yeah,
cool.
All right. Sorry. The second reason was, what if? I mean, this might not be the best time to make some releases, right? New releases. So, like, add new features and things like this. Of course, if there's an emergency, like bugs, so someone discovers an exploit, it will have to be released. But theoretically, we would like to avoid making releases. And 15 days without a release is definitely manageable. Maybe 2 months is manageable. 6 months is not. Like, people will want to roll out features and things like this. So that was the second thing.
Oh yeah, that makes sense. Thanks.
Sure. And Enrico?
Yeah, I just raised the hand when you were talking about ROX 5B, and something pops in my mind. So they will probably affect also the attestation accuracy, if I get it right, because if they have block import very, very slow, they probably have more chance to start importing blocks late and start voting for a wrong head. So I see that the impact is probably also have less effectiveness as a validator. Am I right here?
Yes, absolutely. I mean, this whole extra work could be done in parallel, right? Because all the attestation voting would be done in the CL, where the EL could be able to prepare this transition for the next block.
All right. So you say the block import should be fast, similar to the normal block import? You're saying this?
It will be, well, it should be. Currently, it's not, because I do everything sequentially, or we do everything sequentially in that prototype. But in theory, assuming you've got enough processing power and everything, yes, it should be pretty much the same.
Okay, so you could do that in advance and actually have these 2 seconds just after the last block import, so you have time to, well, not sure. Okay.
This is only true for linear block imports. Any like switching to different branch can be very, very costly.
Right. So the late block reorgs could be a nightmare.
Yeah, that's true. There's also that. Yeah. Yeah. So I guess we need to get more performance basically for that to work. I mean, yes, if you have a late, like if you have a late reorg, clearly some people are gonna miss their slots. That's for sure. This being said, sorry, I'm just thinking all of a sudden, that would not be necessarily entirely true, because you could prepare the block to. So the problem with Verkle is the update, the tree update, like the commitment calculation update. And the problem with this is that it's not a problem. The advantage of this is computing one commitment update is extremely expensive, but there's a batching technique that's extremely efficient. So if we would be able to, if we have to reorg, basically, we could reinsert all the missing blocks directly in one go and still get a good speed up. Yeah, okay, I'm just brain dumping here. There might be a good way to do this, and that might not actually be a problem, but it needs to be investigated.
I'm not sure if that's possible, because if you have a reorg, you will have to compute all the intermediate state roots as well.
Yeah, that's true.
And for that, you need to do the individual per block updates. But I mean, is that really that much? Oh, yeah, you do get more efficiency if you have more updates to batch. Yeah.
I mean,
but I think you'll still have to do it block by block, unless you get a trusted route from somewhere that you're sure is the correct one.
Yeah, that's true. But is this going to be a problem? Yes, because if we have 10K leaves, it takes about a second per block of 10K. So sorry, half a second. Well, okay, worst case is a second, and average case is more like 300 milliseconds. So assuming the worst case, you have to reorg 50 blocks, that's 50 seconds. That's it's not great. But in any case, okay, it has to be tested. Yeah, that was pretty much it for my update. So we can go on to the next topic, unless there's more questions, of course.
Okay. Next topic is the testnet relaunch. Guillaume, do you have thoughts there as well you want to start with?
Sure. Yeah, so we have Kaustinen, which is a testnet that provides proofs and blocks. It's well, it's been working fine, but it's a bit outdated. So one thing, for example, is that we've been discussing is that we've been talking about putting the post state. So currently, Kaustinen only contains proofs for the pre-state of each block. We would like to add the post state as well, see how it behaves. So that was one option. There were currently Kaustinen is also pre-Shanghai, so there's no withdrawals. There's nothing like this. So these were the two features I wanted to try for Kaustinen. Well, for a potential relaunch, knowing that Geth hasn't been rebased yet, that's my current task. And so yeah, it would probably take a month or two to get it relaunched. But while we're relaunching, I wanted to know if there were extra features that we should add. And I know Tanishq had some ideas, I think, about this. So yeah, I'm basically collecting input. What should be different for the new version of Kerstinen? Remind me. So G11, your Tanishq is off this week. Well, that's unlucky. Yeah. So, but what's your name? Sorry, again. G11 Tech.
Hi, I'm Gajender.
Oh yeah, Gajendra. That's it. So which because I know you're part of two teams. Which one are you talking about? Like rebasing on the Shanghai rebasing? Are you talking about Lodestar or I think you're also Ethereum JS, right?
Yep, both have a lot of code merged in the master for DANAP. So, I mean, just to figure out how to not mix it with DANAP would be difficult. Maybe it would be a little easier for Ethereum JS because the activation is based upon the EIP activation. But on Lodestar, we have a pretty deterministic flow of how the hard forks are scheduled. So post Capella, all our code repositories basically make sure that DANAP is the next one. So it will be a bit difficult to figure it out.
So right, if I understand the problem, you won't be able to activate. Yeah, okay, you won't be able to activate presumably Electra if that's still the schedule we're planning to. If we make that schedule, you would have a hard time activating Electra before DANAP, basically, and therefore it would have to also contain block transactions and things like this for Lodestar to join.
Yeah, and I mean, if the testnet is to be launched in 2 to 3 weeks, I mean, it's quite feasible that maybe we can rebase on DANAP because DANAP the spec is now quite stable, and the DevNet spec most likely we can use to rebase everything on.
Yeah, but Guess won't be ready for that. Yeah, I don't think so. I mean, yes, it's. I mean, clearly we do have an implementation of Cancun in Guess, but I don't trust it. I don't trust it enough at this stage that we should attempt Cancun as well.
I mean, ideally, it would be good to have withdrawals sort of part of the next testnet because even if the block is empty, withdrawals do change the state. So, I mean, it's a very good thing to have withdrawals as part of the next DevNet, but yeah, it would be a bit tricky how to basically include Capella for Lodestar. But maybe we can figure it out. I mean,
I mean, ultimately, it's mostly an EL fork. At least at this point, we have this API like requirement on the CL side, but if one client cannot make it, one CL client can make it for this relaunch, I don't think it's too bad. The question is, can Lighthouse do that? I mean, I assume is anybody from Lighthouse here? I guess not. It's Australia. And try to remember, Enrico, are you from?
I'm assuming that it with the difficulty level would be same for all of the CL clients because most of the CL clients are not really configured in that way that you can basically schedule or unschedule a fork. So I mean, but I think maybe it's doable. We can just patch in and figure it out.
Okay. Okay. Well then, yeah, I'll get back to you offline to see if we can organize that. I'm pretty sure Lighthouse should be able to do it because this is what we've been using. Pari, do you remember where we're using Teku as well?
No, we're just using Lighthouse.
Okay. And for Teku, Anybody from Tiku is here?
Yes, but we
oh, yes.
haven't started actually
Mhm.
updating our very old branch around integration with Verkle 3. So we need to pick up the job again and refresh our branch on top of all the things that has been done so far. So yeah, not started yet.
Okay, that's fine. My question was more like theoretical. Would you be able to rebase your old branch on top of like Shanghai, but not having Cancun?
Oh, that's I don't think so. As my initial gut feeling, yeah, we have pretty straightforward and sequential fork applications. So I don't think so, to be honest.
Okay, gotcha. I see there's Zahari from Nimbus.
Yeah, I'm here. I'm from Nimbus, yeah, but I'm not implementing Verkle at the moment. I think Sahari is also here.
Yes, sorry for I was unmuting myself. But basically, we are just starting implementing Verkle. We have a brand new developer who will be focused on that. And he started just a week ago. So we are starting from the lowest layer building blocks.
Mhm.
And we'll go from there.
Okay, cool. But in theory, do you think you would be able to enable Prague or Electra without enabling Cancun?
It's a bit. We have this general problem how to enable certain EAPs, etc., and how to relate them to the hard forks. And we have a solution that works relatively well with compile time flags. Some teams have asked us, testing teams have asked us to provide runtime flags, and this has been a bit more difficult.
Okay,
so we'll probably go for the compile time flags.
Right. I don't see anybody, but maybe I don't know every name here. Is there anybody from Prism? I guess not. Yeah, so I guess for on the CL client, well, I'm going to assume it will only be a Lighthouse thing again. I guess we could also restart Beverly Hills, in which case we can use every single client. That's no longer a problem because Beverly Hills is the same thing, except the proofs are not provided. That's true. We can also join clients post Genesis. Yeah, that's true. I mean, yeah, absolutely. Okay, so I guess that's it for now, and I will write Tanishk to ask him if he's got some extra requests for this relaunch. But otherwise, I assume it will only be sorry, I'm losing my words again. It will be the post state, and there was something else I forgot. Anyway, those two things. Yeah, I think that's it for this topic.
Okay. So next we have Verkle SnapSync.
Right. So I didn't realize. Okay, well, go ahead, Lukash.
So Tanish is not here. I don't have too much on Verkle SnapSync, but I have one message from him I got last week that he was testing stateless execution on Kaustinen. So we can start the node and sync in the background while having execution. And he was able to process new payloads without the state being synced yet. But he had failures on some block with different state root, and he was looking into the issue, and he wasn't sure, but thought that maybe the witness is not correct in the blocks, but he wasn't sure yet. So this is also a good test if the witness is correct, right? So either it's processes wrongly or the witnesses are a problem. But I don't have any follow-up from that. I think it will be next week.
Okay, that's nice. Yes, it's a great test. I used to check the witness. I haven't done that in a long time. So they used to be working. I think Gabriel also. I know, right? You're not checking the proof, right, Gabriel, in your.
Yeah, not yet.
Okay, so it could be that the proof is wrong, but at least the witness should be correct. Oh, right. There was another thing that was missing, and now that you mention it, the Coinbase was missing, or the reward. So that's also something that needs to be added to Kaustinen, and maybe that's what he meant. Yeah. Okay. But otherwise, so okay. So what that thing he's got would be basically SnapSync, right? Except it uses a different proof system.
Yeah, so I think the idea, I'm not entirely sure what's the state, but the idea is to have SnapSync and also have stateless execution in the meantime, right? During SnapSync. So the idea is to be able to execute blocks as soon as you run Nethermind, potentially maybe even like provide a flag not to do state sync at all, but we'll see.
Cool. Okay, well, I guess that's it for the conversation, but that's nice. That's nice to know. Was there anything else on the agenda?
Yes. The other thing on the agenda is state expiry versus the overlay method. I think you want to touch on that briefly, Guillaume.
Yeah, sorry, it's just me talking.
Sure.
But yeah, I also wanted to discuss this. So you know, we have this overlay method where we translate n leaves per block, and it had been discussed. Like the idea, there was another proposal initially, which was to never do the translation, so keep the overlay tree, write to the overlay tree, but never do, like never voluntarily get leaves from the MPT and move them into the Verkle tree. So you would have this 2-tree system for a long period. So definitely more than 1 month, definitely more than 6 months. And then with the help of state expiry, someday this tree would be deleted. Like once state expiry is properly defined and implemented, this base tree, like the MPT, would be forgotten, translated to Verkle in the background and by some nodes. And then when someone needs to access the data that was never translated, that was in the MPT but never got overlaid or never reached the overlay tree, those people would use the state expiry scheme to resurrect that data and bring it into the Verkle tree. Yeah, so there's a bit of a, you know, there's a few problems with this approach. One of them is that it would make Verkle tree dependent on the design of the state expiry, or that would be a Hail Mary. We would just go for it and hope that someday someone will implement that. But yeah, I was just wondering if people were like, if people had an opinion about this. I mean, especially other EL clients. Like for example, Łukasz, would you be completely against this idea?
No. So the question is, do we want to have state expiry? When do we want to have it? Do we have a backup for the state, right? Those are the questions here. And yeah, so if we would agree on the state expiry, in general, doing the transition of state expiry makes sense.
Okay, so yeah, basically we would need to find something. Is there anybody else from an EL that would? Oh yeah, for example, Ethereum.js. So people, do you have any idea about this?
Yeah, I don't see a downside to doing state expiry at the same time as the transition. It does. I mean, the only downside I can see is, well, obviously it adds meat to the actual transition period because we're doing more upgrades at once. But I think it gets us closer to the end vision of Verkle implementation, which, I mean, it's often been presented in pair with state expiry anyway. And it does have the downside of having two trees for a longer period of time. But yeah, personally, initially, when we began talking about Verkle, I thought these two would kind of come in pair with each other. So it kind of reconciles that vision. I don't know. I'm personally in favor.
So, well, technically, you don't really need to have both trees. All you need to do is to have the leaves for the MPT. After a while, once the fork has passed the finalization point, you don't need all the internal nodes because you won't be updating them, right?
Oh, that's true. Yeah.
But yes, admittedly, it means you have two types of data structures that you keep forever, like potentially forever. So yeah, it's for code maintenance, it's not great, especially if we want to have clients that don't care about the past that is long gone. That doesn't help with the simplification, basically. But yeah, it wouldn't be as bad. Yeah, and there was another question for this, which actually is the same as the transition. What would be the gas cost for this? Because if you hit the if your transition is to 15 days, you don't really need to care about being too correct with the gas. You can just say the cost of the gas is just reading from the overlay tree, and then you add a constant cost for in case you have to go into the key value store, because that represents the bottom layer of the MPT. And then you could just say, well, okay, it's going to be a bit more expensive. People who end up in the overlay tree, in the Verkle tree, are going to pay more than they should, but it's only for 15 days. If you do this forever, it's going to be a bit more expensive. I mean, it's going to be more expensive and inadequate for potentially forever.
So you mean that the operations that will be more costly is when one piece of data isn't yet available in the like overlaid Verkle tree, but has to be retrieved from the Merkle try
Right.
and then written down. So because you're doing like two reads and one write instead of just one read, right?
Exactly. But since it greatly complicates the gas model, I would just try to do something. I mean, I don't know if it's realistic yet, but just say you have the cost of reading into the Verkle tree, and then on top of that, you have a fixed cost for reading into a key value database, which corresponds to the MPT. Basically, it's the lazy approach of counting the costs twice, basically, or checking that if it doesn't hit the first tree, then you have to pay gas for the second, for reading into the second tree.
Yeah, would that approach be idiosyncratic to that like transition period? Is that something that's ever been done, like specifying a gas cost that's mapped to the underlying like data structure?
Yeah, no, it hasn't been done, and that's what I'm trying to avoid precisely.
Yeah, I see.
So that's why I wanted to suggest a fixed cost for reading. I guess I'll write an EIP about this to get some proper feedback. But yeah, it would be just assuming you no longer read in the tree, right? In the MPT, because you don't need to update all the internal nodes. So you only keep the bottom key value store, and then you provide a fixed cost for a fixed gas cost for accessing a key value store, really.
Mm-hmm. Yeah.
Karim, I saw you were here at some point. Do you also have an opinion about the what's that called, the state expiry method?
I don't think we can hear you, Karim, if you're speaking.
Okay, maybe there's a microphone problem. I'll sync up with him. Okay. Well, okay, I guess that's it for this topic until Karim can. But yeah, I'll sync up with him. Hey.
I have a quick question on the gas cost during the transition period. So I understand the concern about reading the read and write operations are more costly, therefore have to be compensated by an additional gas cost to compensate for client load. But there's also the transition work, right, which obviously isn't priced in because it's just work that the clients are doing on their side. Is it worth thinking about how clients, I mean, there's going to be a 15 days period in which the clients have much more work to do than they typically have, right?
Yep.
And there's no compensation for that. Has there been like economic analysis as to what the incentives are going to be during that period and what that might look like? Because it feels to me like we're going to increase their load like 5x and just they're not going to have any additional income for that.
Right. So there's the research, the robust incentive group in EF that started looking into this, but they started. I don't actually know if they even started. Josh, do you know if David started working on the topic?
Just very initially, hasn't gone deep yet.
Yeah. So yes, there is going to be research, but it's still, yeah, it's not very advanced so far. Yeah. Sorry, what's your name? And Vehan?
Yes. Hi. Thanks. I was just wondering, like, as the entire network state grows, like, how many more years do you think that can the entire Ethereum network sustain stably without solutions like state expiry to tackle the state book problem? Just wondering, and wanted to get your opinion on this. Yeah.
Yeah. I mean, that's a good question. We don't really know, but the idea is precisely that if you don't have like state expiry, I mean, stateless is precisely the trying to offer a middle point, or I don't know, an intermediate solution, so that the state growth is not affecting everybody on the network, only the people who have to produce blocks. So how long can this go? Yeah. I don't know where even with the MPT, we like there was a presentation by Peter at East Prague last year. We still have a few years ahead of us. Now, if you want a deadline where everything collapses, I don't have that. But I think it's not like state expiry is not super important at the moment. We still have some time to go.
I mean, actually, Verkle trees, if anything, will enable us to postpone state expiry further, because we will be able to allow people to use stateless clients instead, and so it's okay if like the cost of running a node that has the full state goes up a bit.
Just wanted to follow up on that. Because from my understanding, Verkle tree itself is tied to stateless, but it doesn't mean that. I mean, I might be wrong because I'm still new to this space, so correct me if I say anything wrong. But from my understanding, stateless might not occur even though Verkle tree is live on the mainnet. So, and I also saw some analysis that by implementing Verkle tree, because we are storing more data in the database, each client's nodes, the storage might increase as well. So I just wanted to clarify.
No. Sorry,
is
where
this
did you
correct?
see that? That's incorrect. Where did you see that you were storing more data with Verkle tree?
I'm not sure. Maybe I'll get the resource, but I saw it somewhere. But I could be wrong. I just wanted to clarify on this. Like, does Verkle tree increase the storage capacity? Okay,
no,
that clarifies. All right, right.
The transition might, depending on which transition is used, but the ultimate state shouldn't increase it.
Okay, got it.
And so Verkle enables statelessness, but statelessness itself is just a separate thing. So like basically, as soon as we have Verkle trees, it will be easy for anyone to construct a stateless client, and it can actually be done independent. Like there's no requirement for consensus updates or anything. I mean, theoretically, you could have a stateless client now. The only problem with it is that you might encounter witness sizes of hundreds of megabytes, which just isn't practical.
Yep. So, like I said, Nevermind is already implementing a stateless client, kind of.
Did you mean a MPT client? Because I think that's what Dankron meant.
Yeah, no. I know that. Yeah.
The Verkle one.
Okay, yeah.
Cool. Thank you, Wehan, for the questions. Anything else, Guillaume, on this topic?
Nope. I think, but I don't know if Karim's microphone started working.
I think
But
he
I'll-
dropped off.
On and
Actually.
coming back to try to get it fixed.
Okay. Oh wait, because Matt, you're also
Yes, I
busy,
mean,
right?
from our perspective, this is the same question, right? About coinciding the Verkle transition with statelessness, right? Or with a stateless transition. We're going back to the previous topic. Yeah, from the basic perspective, it's not. I mean, it's just complexity. Since we're already kind of adapting our bonsai format, it should be relatively straightforward to do them at the same time, just based on the work, on the way that stateless could potentially look. I defer to Kareem on the specifics, but I'm weakly in favor of doing them at the same time, just because it's going to be already complexity. But at the same time, it doesn't really matter because we'll have to adapt our pattern anyway. But I think Kareem's mic is back on, it seems.
Could you hear me?
Yes, gotcha.
Yes. Sorry, could you repeat what you said, Matt? I was disconnected.
Yeah, so we went back to the question about doing the transition to Verkle at the same time as potentially adopting statelessness. And I think from our perspective, since we're adopting a new format for Bonsai anyway, reworking it for stateless at the same time would not be too much of an extra lift, especially if we're putting it in the same fork. But that's kind of my personal opinion based on how it's working. I wanted your opinion there too.
Yeah, thinking the same because as you said, we are trying to modify Bonsai to work with Verkle tree. So if we can do all of the modification at the same time and not do several rewriting of this part, it would be better.
Right, but the question was, okay, at least I didn't see the connection. In theory, would you be okay with state expiry, or do you have some strong oppositions to this method?
For the moment, I don't see any problem, to do that.
Okay, so that could be a nice backup. All right. Yep, thanks. That was all for me on this topic.
Okay, great. So we only have a few minutes left. Guillaume, do you want to save this for the next call? We did have something on the agenda to discuss pre-image distribution, general discussion, and potential next steps there. But maybe that's best for the next call.
Yeah, I'd be okay with that. Finishing early.
Sure. Okay. Yeah, no need to use the full time. We can end early there unless anyone has anything else. Okay. Oh, one more from Wehan, yes?
Yeah. Oh, sorry. Just wanted to ask because I'm new to this space and I've just recently been doing research on this. And I recall that Verkle 3 is set to be launched after the Cancun upgrade, which is in Prague, if I'm not mistaken, which I'm assuming is going to be next year. So from your side, is there a specific timeline that when Verkle 3 is going to be on the mainnet, perhaps like during the first half of next year or second half of next year. Just wanted to know about this. Yeah.
Well, I mean, one of the questions is when is Cancun delivered? Because we need to make sure that that this first thing is delivered. So, okay, the short answer for your question, no, there's no timeline. We are also dependent on Cancun, and then there's once Cancun has been delivered, all the clients will start diverting to Verkle, and there's currently, I mean, I'm still hopeful we can get it by the end of next year, but there's definitely no promise on that.
Yeah, I mean, it's likely that Cancun will be delivered this year. I would expect it before DEF CON at least. I'm not sure if Verkle trees by then will be ready to be the next hard fork. I think that we need a very convincing story on the transition in order to be able to push that. And otherwise, there's probably going to be EOF, which really want to get their updates in and have been pushed back several times.
Okay, great. Well, that's it. Thank you, everybody, for joining. See you next time.
Thanks.
Bye.
Thanks, everyone.
Bye.
Thank you.
Bye.
Bye-bye.
Bye, everyone.